Good day. Welcome to today's demonstration session. In this video, we will be testing the ventilation functionality of an ICU ventilator using the Fluke VT900A gas flow analyzer. The Fluke VT900A gas flow analyzer is an accurate, easy-to-use, portable, and reliable gas flow analyzer used to test all types of gas flow equipment. On the Fluke VT900A, we have a single flow channel which comprises the flow inlet and the flow exhaust. We also have the touch screen, we have the power button, and we have several ports: the low flow, the ultra low pressure, the high pressure, and the low pressure ports. These ports are used to check other gas flow equipment such as oxygen concentrators and anesthesia machines. The high pressure port is used to check pressurized gas sources from wall or tanks. On the VT900A, we also have the O2 sensor door, which is where the oxygen sensor is housed. We have the input accessory for the anesthesia tester, which will be shown later on. We also have the breath trigger input. We have the battery status light indicator. We also have the input for the power adapter. Behind, we have 4 points, which are used for the visa mount. We also have the battery door and a bail, which can be used to place the VT900A in an upright position. Accessories include the bacterial filter, which will be connected to the flow inlet of the VT900A, the power adapter with interchangeable heads, this 1.2 meter silicone hose. We also have the vapor anesthesia tester, which will be connected to the back of the VT900A and is used to check for gases from vaporizers on the VT900A. We have the adapter connectors, which are used to connect the VT900A to the gas flow equipment. We have the USB cable, which is used to connect to the VT900A to extract the saved data. We have the manual, which contains information on abbreviations and also the details on VT900A. And lastly, we have the certificate, which shows the calibration information on the VT900A. The VT900A has a single flow channel, which comprises the flow inlet and the flow exhaust. There are also several ports which are used: the ultra low flow, the ultra low pressure, the high pressure, and the low pressure ports. The high pressure port uses the standard DISS oxygen connector and is used to connect to gases in pressurized containers. The other ports can be used on gas flow equipment such as oxygen concentrators and anesthesia machines. Here we have the oxygen sensor door, which houses the oxygen sensor for the VT900A and lasts for 2 years. We have the accessory inputs, where the anesthesia tester will be connected. We have the breath trigger inputs, the battery status indicator, and the connection points for the power adapter. Behind, we have 4 points for the visa mount system. We also have the door for the lithium-ion battery, which lasts 8 hours. We have the bail for the VT900A, which is used to place the VT900 in an upright position. In terms of accessories, we have the bacterial filter, which will be connected to the flow inlet of the VT900A. This is used to prevent contaminants from entering the VT900A. We also have the power adapter, which is used to charge the battery of the VT900A. And we have interchangeable heads, which can be switched here and connected also to charge the VT900A. We have the 1.2-meter silicone hose, which is used in addition to the anesthesia tester as an accessory. We also have the anesthesia tester, which is used to test for gases from the vaporizer when testing the anesthesia machine. We have the connectors, which are also connected to the Y-piece of the gas flow equipment and connected to the VT900A as well. We have the USB cable, which can be used to connect to the VT900A and whatever device is used to extract test information from the VT900A. We have the manual, which contains information on the VT900A as well as abbreviations on the test device. We also have the certificate of calibration, which gives more details on the calibrated VT900A. The Fluke VT900A can be used for repair verification as well as preventative maintenance on various types of gas flow equipment. It should be used by trained service technicians as well as clinical engineers. Once you power on the VT900A, the oxygen sensor should be calibrated first before connecting to any gas flow equipment. To get to the calibration section, click Menus, Calibrate Oxygen, and follow the steps. The first calibration will be done at 20.9% oxygen. Ensure that a bacterial filter is used. Connect the adapter to the bacterial filter and to the flow inlet of the VT900A. Connect the Y-piece to the VT900A and the test lung with a stated compliance to the flow exhaust. Set the oxygen concentration on the gas flow equipment.
So to calibrate for our 21% oxygen, we'll click on the O2 percentage to 21%. And then we enter.
Click Next on the VT900A. Calibration takes 2 minutes. Once calibration at 20.9% oxygen has been completed, set the oxygen concentration to 100% oxygen.
So on the ventilator, we click the O2 percentage and set to 100% oxygen. Then we enter.
Click Next on the VT900A. Calibration takes 2 minutes. Once the calibration is complete, a notification message will be displayed on the screen of the VT900A. Click OK to save the calibration. This has automatically been saved on the memory of the VT900A. Before you start ventilating, ensure that there is proper connection of the test lung, the bacterial filter, the connector, and the Y-piece to the VT900A. The stated compliance of the test lung is 20 ml per cm H2O. There needs to be some setting adjustments on the VT900A. To do this, go to Menus, Setup. Here you can select what gas, correction mode, breath detect mode will be used. For the gas, oxygen is the preferred gas. Select oxygen and click OK. For the correction mode, ambient temperature and ambient pressure will be used. Click on ATP and press OK. For the breath detect mode, It should be set on bidirectional, as the ventilator will be using the inspiratory and expiratory flow. Select bidirectional and click Done. Go back to the main menu. Click Test ID and type whatever information you need to save for this particular gas flow equipment. The model of the equipment has been typed here. Click Save. We will be using two modes for the ventilation, the volume control mode and the pressure control mode. We will start with the volume control mode.
For the volume control mode, it has to be set on our ventilator. So it's already set to volume control. So we have to set our parameters which we want to use. For the respiratory rate, we have 12 beats per minute. For our tidal volume, 500. The PEEP, 5, and our O2, 80%. And then we press the accept.
Before you start ventilating, ensure that the units on the VT900A match the units on the ventilator. To get to this section, click Menus, Units, and confirm that the volume unit matches the units on the ventilator. We will be using milliliters. Click on milliliters and click OK. Also go over all other units and confirm. Go back to the main menu and start ventilating.
So we'll start ventilating now.
Once you start ventilating, click on the airway selection. You have options for flow, pressure, volume, and oxygen, which give you outputs as the ventilator is functioning. You also have the graph options, where you can select flow, pressure, volume, or oxygen. Click on whatever option. I click on volume, and a graph appears for the volume mode. Compare the readings on the VT900A to the graph on the ventilator. Click Save. You have the option to save as data, graph, or recording. Save whatever option. The next option is to compare flow. Compare the readings on the VT900A to that of the ventilator. Click Save. The next selection is the breath view selection. Here you have different parameters, which will all be from the ventilator. You have TI, which is for inspiratory time, TE for expiratory time, TIH for inhalation time, EH for exhalation time, IE for the inspiratory-expiratory ratio, BPM for the breaths per minute, and so on. Compare the readings here to the settings on the ventilator. Click Save. You can save as data or recording. On the menus option, there is an additional section for special tests. Click Menus, Special Tests. There are various options to select. The trend test, for instance, allows you to pick a particular parameter to check for on the ventilator. For instance, we'll be picking the BPM, which is breaths per minute. Click Next. Input a test time and a limit and start. We will be using 1 minute and a limit of 5%. Click Start. So once this has been completed, compare the results, which we have 12.1 breaths per minute, to what was set on the ventilator, which is 12 breaths per minute. Click Save. All information is saved on the onboard memory of the VT900A, which has the capacity to store over 500 tests. Go back to the main menu. You can always select another option. For instance, CMPL, which stands as compliance. This will calculate the compliance of the test log. Click Next. You can always reduce the test time and limits. Press Start. The compliance stated is 24.6 ml per cm H2O. Click Save. Return to the main menu. And change the mode of ventilation.
For a brief moment, we stop ventilating so as to set the parameters for our pressure control. So we set on our ventilator the pressure control mode, and we set in our parameters. For the respiratory rate, we have 12. For the inspiratory pressure, we have 18. So we'll click on it and set it and we enter. For the PEEP, we'll be using 10. And for our oxygen percentage, we'll be using 70. All these parameters are set using the manufacturer specification for this mode. So press our accept key. Okay. And we start ventilation.
So once ventilation has been started, go to the airway option and compare the readings to that of the ventilator. In addition, the graph mode also. You can select whatever option as we did previously and compare the graphs. We'll be selecting the pressure option in this. So you compare the readings on the VT900A to that of the ventilator. Click Save. Save as data, graph, or recording. Go back to the airway option. In the breath views mode, you can also compare the different parameters as mentioned earlier to that of the ventilator. For instance, the oxygen percentage here is 82.6, while on the ventilator we have set an oxygen concentration of 80%. Click Save. To view all saved results on the VT900A, click Menus, go to Memory, scroll down to the name of the saved test ID, click List, and all the information that have been saved will be presented here. Select whatever information and click View. For instance, here is a graph that was saved earlier. Go back to the main menu. In addition to the special tests mentioned previously, there is also the stacked volume test, the high frequency test, the ultra low pressure leak test, the airway pressure leak test, the high pressure leak test, and the low pressure leak test. These tests are more common with the anesthesia machines, but since we are using the ventilator, we only checked the trend test. The stacked volume test can also be used. It gives you the information on the total volume inhaled and exhaled. For instance, for a total of 12 breaths, we can calculate the stacked volume. Click Start. Once this has been completed, you can see the total volume inhaled and the total volume exhaled. Click Save. Return to the main menu. And that will be it for the calibration. Sorry. And that will be it for the performance verification of the ventilator. Ensure that all readings that are compared on the VT900A are in close value to that of the ventilator. Where there are proximities, for instance, the oxygen concentration percentage, if there is quite a large gap, check that the oxygen sensor of the ventilator is not expired. If it is, replace it. Also, for the PEEP settings on the VT900A, if the values displayed on the VT900A are very large in comparison to the ventilator settings, change the test log, as the resistance on the test log may not be as high as it previously was. We have come to the end of this demonstration session. As mentioned earlier, ensure that all values on the VT900A are in close proximity to the value set on the ventilator. For instance, the percentage oxygen set. If there is a large disparity between what was set on the ventilator and the VT900A, ensure that the oxygen sensor of the ventilator is checked. If expired, do replace. In addition, the PEEP setting on the ventilator should also be in close proximity with the values displayed on the VT900A. If there is also a large disparity, the test lung can be replaced, as the resistance of the test lung may have reduced over time. Now that we are done, we are going to stop ventilating and disconnect the white piece of the ventilator. Also remove the test lung and the bacterial filter. For more information on how to perform this verification test with the Fluke VT900A gas flow analyzer, contact MedCourt Support Services in Nigeria. Thank you.